Chapter 2, Section 3, Deductive Reasoning. Symbolic notation. Conditional statements can be written using symbolic notation, where the hypothesis is represented by P and the conclusion can be represented by Q. An arrow is read as implies that. Remember with conditional statements, so far we've written them in if-then form. And the if part was the hypothesis, and the part that came after then was the conclusion. The original conditional statement would be notated as P and then your arrow Q, or P implies that Q. And the converse, remember the converse is when you switch the hypothesis and the conclusion, so it would be Q arrow P, or Q implies that P. Symbolic notation. A biconditional statement can be written using symbolic notation also, where the hypothesis is still P and the conclusion is still Q. An arrow with a double arrowhead is used because remember that a biconditional statement is the same as writing a conditional statement and its converse at the same time. So biconditional statement example, the P double arrowhead Q, sometimes or most often a biconditional statement will be written as P if and only if Q. Remember, if and only if are the key words to look for when you're looking for a biconditional statement. Symbolic notation example says let P be the value of x is -4 and Q be the square of x is 16. A asks us to write P implies Q in words, so the original conditional statement in words. To write it in words, I'm still going to use if and then because it's a conditional statement, so A would be if the value of x is -4, then the square of x is 16. B asks us to write the converse. Notice it's using symbolic notation, so it says write Q implies P in words. We're just switching the hypothesis and the conclusion. So it would say if the square of x is 16, then the value of x is -4. C asks us to decide whether the biconditional statement P double arrowhead Q is true. For C, remember to write a biconditional statement, the conditional statement or part A and the converse or part B has to be true. This cannot be written as a biconditional statement because in part B, x could also equal 4. -4 squared is 16, but 4 squared is also 16. So there is a counterexample for B, so I cannot write it as a biconditional statement. The negation symbol is this little squiggle. The squiggle negates the hypothesis or the conclusion. The inverse of a conditional statement could be written using the squiggle P implies that the squiggle Q. And the contrapositive could be written, remember contrapositive is when you switch and negate, so it would be the squiggle Q implies that the squiggle P. An example says let P be today is Monday and Q be there is school. A asks us to write the contrapositive of P implies Q, and B asks us to write the inverse of P implies Q. Then it says to write it in both words and using symbols. So the contrapositive, remember, is when we switch and negate. So using symbolic notation, it would be squiggle Q implies that the squiggle P. And when we write it in words, it would be if there is no school, then it is not Monday. For part B, writing the inverse is when we leave the hypothesis and conclusion in the same order, but we're negating both of them. So B would be the squiggle P implies that the squiggle Q. And in words, it would say if it is not Monday, then there is no school. Deductive reasoning. Deductive reasoning uses facts, definitions, and accepted properties in logical order to write a logical argument. Inductive reasoning uses previous examples and patterns are used to form a conjecture. An example says, is the reasoning inductive or deductive? A says Josh knows that brand X computers cost less than brand Y computers. All other brands that Josh knows of cost less than brand X. Josh reasons that brand Y costs more than all other brands. This example is not using facts for everything. The key words here are all other brands that Josh knows of. So Josh can't possibly know of every single brand of computers available and how much they cost. He is using his experience to reason. Remember, when you're using experience or previous examples, it's going to be inductive reasoning. So A would be an example of inductive reasoning. B says Josh knows that brand X computers cost less than brand Y computers. He also knows that brand Y computers cost less than brand Z. Josh reasons that brand X costs less than brand Z. In this argument, it is all based on what he knows. So he knows how much brand X, brand Y, and brand Z computers cost. It's not taking into account any other computer cost. It's only talking about these three that he knows for a fact. Because this is using facts, it is deductive reasoning. The law of detachment says that if P implies Q is a true conditional statement and P is true, then Q is true. So what they're saying is if you have a conditional statement and the hypothesis is true, then the conclusion is going to be true. State whether the argument is valid. A says Michael knows that if he does not do his chores in the morning, he will not be allowed to play video games later, the same day. Michael does not play video games on Friday afternoon, so Michael did not do chores on Friday morning. If you look at the very first sentence in this argument, it says Michael knows that if he does not do his chores in the morning. So he does not do his chores in the morning would be the hypothesis. It says he will not be allowed to play video games later the same day. So not being able to play video games would be the conclusion. This is a true statement. Remember what we just talked about says that the hypothesis has to be true, and then we know that the conclusion is true. Well, the next statement says Michael does not play video games on Friday afternoon. It's telling us that the conclusion is true. I cannot know that the conclusion is true to reason that the hypothesis is true. It has to be the other way around. So this example A is not a valid argument. If you read B, it says if two angles are vertical, then they are congruent. So two angles are vertical is the hypothesis. The conclusion is that they are congruent. The next statement says angle ABC and angle DBE are vertical. So they have stated that the hypothesis is true, and then it says so angle ABC and angle DBE are congruent. It told us that the hypothesis is true. It gave us a true conditional statement. So I can conclude that the conclusion is true, which is angle ABC and angle DBE are congruent. So this is valid. The law of syllogism says that if P implies Q and Q implies R are true conditional statements, then P implies R is true. Notice that in this example, Q is the conclusion of the first conditional statement and the hypothesis of the second conditional statement. When you have the same thing as the conclusion of one and the hypothesis of the other, you can drop that out and you can put the hypothesis of the first conditional statement and the conclusion of the second conditional statement together to combine another true conditional statement. An example says write some conditional statements that can be made from the following true statements using the law of syllogism. One says if a fish swims at 65 miles per hour, then it swims at 110 kilometers per hour. And 2 says if a fish can swim at 110 kilometers per hour, then it is a sailfish. Notice the conclusion of the first conditional statement is it swims at 110 kilometers per hour, and the hypothesis of the second is that a fish can swim at 110 kilometers per hour. Because these two are the same thing, I can drop those out, and I can use the hypothesis of the first, if a fish swims at 68 miles per hour, and the conclusion of the second, then it is a sailfish. So I've dropped out the 110 kilometers per hour, and I can say if a fish swims at 68 miles per hour, then it is a sailfish. Take a minute and pause this video, and you can try to combine other statements to form, using the law of syllogism to form true conditional statements. The next example says Casey goes to a music store. Given the following true statements, can you conclude that Casey buys a CD? It says, if Casey goes to a music store, she shops for a CD. So hypothesis is Casey goes to a music store. Conclusion, she shops for a CD. The next statement says, if Casey shops for a CD, then Casey will buy a CD. In this case, the hypothesis is Casey shops for a CD. The conclusion is Casey buys a CD. Because the conclusion of the first conditional statement and the hypothesis of the second are the same, I can drop the part that says she shops for a CD, and I can say if Casey goes to a music store, then Casey will buy a CD. Because it says that Casey goes to a music store, I can say that Casey will buy a CD using the law of syllogism. Today's assignment is on page 91. It's numbers 8 through 42 even, 40 and 45 through 48.